Right. So next up, we have a talk by Cody Burns. So Cody is an Ethereum Classic OG. He is also a director of the Ethereum Classic Cooperative, so he can sack me if I'm rubbish. So big warm hand for Cody.
Good afternoon, everyone. As Bob mentioned, I do a lot of stuff with Ethereum Classic, but my day job is I'm an enterprise architect at Accenture. So what that means is I work with the largest companies in the world and helping them develop blockchain solutions that solve their real-world problems. So over the last year, one of the things that we wanted to look at, and we've had our labs working on, is what's the relationship between AI and blockchain, and where can we leverage the two together? And that opened a huge can of worms because there's nothing more hyped right now than AI or blockchain. And whenever you combine the two of them, you will find thousands of useless projects and scams. And everyone has an idea of what they should be. So what we set out to do was develop a framework of how we could evaluate what AI for blockchain was and how we can better look at it and how we can think about it in a different way, maybe something more methodical. So what we're going to go over today is the introduction, the basics of what we found, the combination of blockchain and AI, and what that looks like, and then specifically the difference between AI for blockchain, blockchain for AI, and then the combination of both blockchain and AI together, and how they can work and build a better solution for each other. So introduction, first of all, what is AI? How does it fit into all of this? And the real simple answer is, whenever you're trying to sell a project, that's whenever you're developing an AI solution. Whenever you're trying to hire somebody, you're looking for machine learning. And it basically boils down to statistics and data science and math. So it breaks up into many different categories. You can see 9 of them listed here, but the realm of artificial intelligence basically boils down to using a function to boil down a set of data and match with the answer that you're looking for, whether you can give a probabilistic answer of, does this data match the pattern that I'm looking for? Blockchains and DLTs, hopefully everyone's at least familiar with this technology if we're here. So the big differences that I'll touch on real quick is Accenture's work, we work with private and permissioned blockchains, whereas Ethereum Classic is a public permissionless. So there are valid use cases for both of them. And for machine learning and AI, there's also use cases where it makes more sense to do a private permissioned chain between a consortium. And there's also use cases where it makes sense to do stuff on the public and permissionless. And we'll get a little into that here in a moment. So as I said, our teams in the lab put a lot of work in the last year. And we put out a white paper on powering or powered by blockchain, realizing AI's full potential. And I'll share the link after this. But we went through and found use cases where there's actual value in combining AI and blockchain and how they can work together. So the real reasons for using it are the same reasons that people like to use blockchain for money. You have the audit trail, you have the trustlessness, it's tamper evident, and there's security built into the protocol. So you don't have to worry if the data that you're getting is valid or if it's up to date, because everyone has the same data at the same time. And this is a huge benefit for modern AI systems. If you haven't been paying attention to the AI space in the last 5 to 10 years, as blockchain's been going crazy, so has AI. There's been huge advances in open source for AI. TensorFlow and Python's tooling around it have made AI incredibly accessible to everybody. But the problem is that the data that gets trained on it goes through a black box and then gets put out as a solution. So you either take the data and assume that everything's correct and do your work on it, or you have to retrain the model yourself entirely every time. And that gets tedious and it can lead to mistakes. So our methodology, I won't drill down on this slide too much. We broke it down into 3 broad categories: AI for blockchain, smarter blockchains, and distributed ledgers. So what this is how we can use AI to make blockchains more efficient, how we can get more value out of them. Blockchain for AI is how we use blockchains to make AI better. So whether that be public transportation systems or medical solutions or federated learning, all that falls under the category of blockchain for AI. Blockchain plus AI is the missing middle. It's where the two meet. This is, some of you may have seen Bridget on Telegram. So it's making the user interfaces where conversational AI can help people understand the blockchain better. They don't have to worry about numbers or hashes or wonky, long hexadecimal codes. They can talk to AI and have answers in human terms. This is our tree. As I said, we broke it down into 3 categories, and we have split out which elements fall under each tree. And these are the ones that we're going to be going over today. So starting out, AI for blockchain, how we can make blockchain better with AI. One of the big things if you've been following the Ethereum main chain, is for the proof of stake system that you need verifiable delay functions. And one of the things that can help with this is we can make smarter consensus mechanisms by utilizing AI and its training models. So you don't have to worry about doing squaring numbers repeatedly. You can use trained models, and it can help in the process and reduce energy costs. The other big innovation that we've seen is useful mining work. One of the biggest complaints against proof of work systems is that we have big warehouses of ASICs that are just hashing numbers all day, and they don't do any valuable work. There was a project called GridCoin a few years ago, and they had developed proof of research. So all of the mining equipment was working on folding proteins. So this is work that's part of a MIT initiative where they send out large sets of data. So it can be radio signals that were received from SETI or protein folding that's needed for building new medicines. And that gets sent out to users at home. And whenever their computer has idle spare time, instead of going to a screensaver, it starts processing these scientific formulas and folding proteins. And the proof of research or proof of useful work, instead of mining and doing hashing algorithms, it actually folds proteins and generates a proof that it had done the work and returns it to the user who sent it. So the proof of work isn't just burning energy and making numbers, it's actually providing valuable scientific feedback as well. Smart contract auto coding. GitHub has been an amazing tool for social coding. It's given users access to code that we never would have had before. I think 32 million users is what was on the slide earlier. And all of this data and code is just sitting there idly, not helping anyone. So what we've seen projects start doing now is they're using generalized adversarial networks, which basically means you feed all of the light code into the AI, and then it can generate code that looks like it's supposed to look. It can write the correct function that you're looking for. So if you have the same function as 45 other contracts, when you start typing it, it can complete the sentence for you. It can correct your syntax errors. And so the coders are able to move faster because they're pairing with the AI system. You don't have to reinvent the wheel every time. It can go through any language or any smart contract, and it can find the mistakes for you as you're going along and help you avoid making costly mistakes like reentrancy errors or just spelling or things like that. So it's a really helpful thing for people that don't program all the time and you need to get something done. So lawyers, doctors, and people in other industries who are looking to do smart contracts, can fill out a form, and then the AI can generate all the contract code in the background without having to go through individually and write out all the functions themselves. Blockchain analytics. So one of the biggest problems with blockchains is that they are permanent, and everything you put into it is also permanent. If you make a mistake whenever you're doing data entry, that becomes a very, very costly endeavor. If you're doing manufacturing or track and trace, and your data entry is off or your API is wrong, then you have huge problems because you can never go back and correct it. So one of the things that the analytics can do is it can help with sanitizing data as it goes in. It can map the transactions that you already have going and detect anomalies. So fraud detection and recommended actions on those frauds can happen all in real time. As the transactions are coming through, you can flag transactions as bad or possible fraudulent or possible criminal activities, or if the temperature sensor's noticeably out of alignment. You can know this ahead of time before you have to wait 40 blocks down whenever you finally get around to looking at your data. This can happen in real time using AI. So blockchains for AI. This is the more exciting stuff, I guess. So federated learning. The easiest way to think about this one is there's no real value in being the best car company that develops an AI that doesn't kill people. There's no value in being the best hospital that knows how to cure cancer. That data is universal. It's for everybody. So federated learning allows multiple companies to train the same AI on the same models in real time, and you can follow the train back. So after a car wreck, you can see why the decisions were made by that AI that was driving the car. It's no longer a black box that has just data put into it and then you get something out the other side. This federated learning allows us to build a forensic, for lack of a better term, AI psychology. You can go back through the chain of transactions every time it's got a training data or every time a decision was made, how it led up to where it is now. And this is an amazing breakthrough for things like cancer research or malaria or diseases where you don't want to share all of the patient information, but the data does need to get out there. It does need to be shared. And right now, there's not a good way of doing that. As I said, we've had a huge advance in AI, but we have not had a huge advance in data sharing or model sharing. Right now, it's one company will build the data, they have their own model, and it doesn't do anyone any good because they don't know what data it was trained on. With this, you can see the training data. You can see what differences the training data made along the time. And as I said, as the auto wreck happens, you can go back and see why the decision was made and how to correct it in the future. Decentralized AI service markets. So one of the things that 2017 brought us was that everybody wanted to be a miner in Bitcoin or Ethereum. So everyone went out and they bought video cards and overpowered computers, and now they're sitting there idly doing nothing. The one thing that also happened at the same time is that AI started using GPUs. So the exact same hardware that used to be used for mining can also be used for crunching numbers for AI in a distributed system. So since blockchain is open and everyone open and transparent, you can have possibilities of doing stuff like cloud computing, selling off your spare hard drive, your spare processes, running AI algorithms on your old mining equipment, making a profitable market out of that. Rather than mining Bitcoin, you're now crunching training data for a TensorFlow. Health data. It's 2019. Everyone walks around with collecting data all day, every day. Heart rates, steps, endless amounts of data is collected by your phone. You have the ability now to be able to sell that data back to other companies. And blockchain is a tool that enables that. It allows you to safely do it in a distributed way without giving all your personal data that you don't want to. So we can use that data also and develop a better training set. One of the ways that Tesla was able to advance their self-driving cars was that they turned on all of the AIs in all of their cars, and they just followed drivers. The AI was training along with the driver, so it would make the same moves. If it was coming up to a turn, the AI would see whether it would turn left or right. And the AI never took control of the system, but they just used that data to train it and reinforce it. Now imagine if you did that for every car in America at once. You have years jumped ahead. And so all of this is possible with the blockchain. We're able to put all the data into a system and then be able to process that in real time. You don't have to worry if you have the latest model because your model's always synced. You're able to pull from the data store wherever it is, even if it's just a marker on chain, and you're using IPFS to store the actual model data. You know that you have the most up-to-date model at all times. Does anyone know the last time they changed the software version in their radio in their car? I don't think so. But with blockchains, we can make sure that our AI is always up to date, and you don't have to worry whether you did the latest flash or whether your car company is using the best algorithm at not running over pedestrians. All of the data can be mutualized and used to help save lives. Prediction platforms. Augur was one of the first ones to launch on the Ethereum mainnet, but prediction as a service, allowing businesses to see what people are thinking in real time. And so building these prediction markets out and using them for logging and rewarding of other users is a big market that's going to be opening up in the future. So I'm trying to speed along. AI and blockchain. So AI and crypto trading, which is also very interesting to a lot of people. So if you've used any of the crypto markets, you may have noticed that there's always transactions going through. And a lot of this is the AI in the crypto trading. You set it up on the patterns that you're looking for, and then the transactions happen automatically. And this is also a huge market, providing analytics on this, providing real-time updates. And so it's not necessarily AI on a blockchain or blockchain and AI, but it's working in concert with it. So it's allowing traders to perform actions and that they wouldn't be able to do in real time. And I believe with that, that's our last slide. And we have a glossary at the end of this also. All right. Are there any questions? Yes, Donald.
You mentioned marketplace.
Mm-hmm.
So the AI agents or machines that are doing the data, etc., is off blockchain, and the blockchain serves like a complementary system to make it trust minimized and to distribute the work, I guess. And there's a component of a marketplace I read. Is that marketplace going to be on blockchain or off blockchain?
The ones that we've seen have been on blockchain. That's what they're looking for. It allows for the escrow of the funds. That's something that's not really, you can't do through PayPal or through, you could do it through a third party, but then that just complicates and adds cost on top of it. But if you give your training data set to a random stranger on the internet, you don't have any real assurance that they're actually doing any work on it. They could just give you back the trained model and it had nothing to do with your data. So by using the blockchain and an escrow contract and some verifiable proofs from the data, you're able to prove that the data that you gave them, the training set, was actually used in the model for training. And so that's a big benefit. And it allows anyone to do it. You don't have to register and give all your information. You could pick up jobs piecemeal.
So there was a talk about maybe 6 months or a year ago by Peter Thiel, and he said that, oh, I'm right
There
here.
you go.
Yeah.
Yeah.
And he said there's two factors which are kind of driving 21st century technology, which is AI, which is an inherently centralizing force, because the more data that you have, the more powerful your models can be, and it's just better than the models with less data. And then there's blockchain, which is an inherently decentralizing force, in which, you know, you're trying to distribute amongst as many different parties as possible. So I'm curious, do you sort of see that as being like two opposing forces there, or what do you think about that idea?
I think that's the wrong mindset that he has. So right now, if you would have asked Google or Microsoft or any other big tech company, that's what they would tell you, is that having the most data is what gives you the most value. But that's also because they use their models to train for whether you want to buy this brand of soap or another brand, or how long you looked at something on a web page. But for humanity, the best solution is going to be something that is distributed. We can provide all the data that we can, and then all share the same solution on it. Like I said, there's no real value in being the best at curing cancer if everybody else is still dying every time they go to a different hospital. So I do think that the two, as their model is right now, are competitive. So AI is mostly centralized. So there's a big race to get as much data as a company can, so that they can say that their AI can beat the world's best Go player. And it's not a very open or sharing market. All the tools are open source, but the data, the value is in collecting as much data as you can and having the best model. And that's not what works best for the general population, at least in my opinion.
Yeah, so with regards to sample sets, like obviously it's a competitive advantage, you know, if you've got this larger data set and you're able to, depending on who your customer is, but in the interest of like the public good, like to your point about, you know, cancer, is there some entity, or is there discussions with regards to some sort of entities that could articulate the value of this larger data set that isn't owned or manipulated by any one entity, like, you know, some sort of certification or something, where it's like when a consumer goes to buy a car, they're like, oh, well, this car is governed by this AI from this decentralized entity. You know, has it gone that far, as opposed to saying, well, it's company A that is solely in charge of what this particular, how this car is particularly governed with regards to the AI?
There's not yet that I know of. There's no government agency that's looking into this and saying this data should be public, this is for the public good, versus this is what a company A or B should be trained on. So that was one of the reasons that we were looking at blockchain and AI, is because it is such an open space, and there's such big buzzwords right now that it's hard to pin down what exactly someone means when they say they have an AI project, or when they say that they're doing something with a blockchain. So there is no clear-cut, these are the use cases that we want to be public, and there's no driving force behind it right now. This is still the very early infancy of the combination of the two.
And should these larger entities not in some way be, if not incentivized, mandated to contributing their data sets towards the greater good of humanity with regards to you know, these particular endeavors? They can still utilize it for, you know, market advantages, but some sort of philanthropic giving, you know, where they're actually giving their data set.
And that's where eventually it would be some type of government entity could make a mandate that if you're operating driverless cars, you will use this system. And that's most likely where you would see the innovation coming down, would be from the top down. Of if you want to drive on freeways, then you're going to have to use this system. Or if you want to be a company that cures cancer, you have to give some data back. So it's going to take some initiative from something to force companies to want to use it for the public good. It's not in there's no business value in necessarily sharing the data, other than you're saving lives, and it's everyone's data.
Yeah, it's almost like, you think of it like organ donation. You know, you check that box on the card and you're like, yeah, well, if and when I don't need them anymore, you know, this will be contributed to the greater good.
That's right. Anyone else? Thank you.
Thanks, boss.